Here we go with angle proofs reference. If you thought segment proofs were good, just wait till we get to angle proofs. So again, when we look at the proofs, now that you've got some experience doing proofs and you look at the reason column, remember the reasons that back it up are properties, their definitions, their theorems, and postulates. So some of the new, you've already seen the properties of equality, that hasn't changed. And you know the properties of congruence, reflexive, symmetric, and transitive properties. But some definitions that I want to go over for angles are this. Definition of congruence. Remember, it's kind of like the segment congruence. We either add on that congruency mark or we take away that congruency mark. So definition of congruence, angle A is equal to measurement of angle B. So whenever it has an M in front of it, means we're talking numbers here. That the measurement of angle A is equal to the measurement of angle B. But the congruency part is this. Angle A is now congruent to angle B. And it's biconditional, so it can go both ways, right? That's biconditional. Definition of angle bisector. An angle bisector divides an angle into two equal parts, just like segment, just like the bisecting of a segment, the midpoint. So an angle bisector divides an angle into two equal measures. The definition of complementary angles. Complementary angles are complementary if and only if the sum is 90 degrees. Again, that's that biconditional statement. And the definition of supplementary angles, again, angles are supplementary if and only if, biconditional, the sum is 180. Definition of perpendicular says perpendicular lines form right angles. And the definition of a right angle is a right angle equals 90 degrees. So perpendicular lines form right angles. Definition of a right angle is an angle equals 90 degrees. Postulates, very similar to the segment addition postulate. Angle addition postulate, which we went over in Unit 1, says that the measurement, remember that M, that's key because it's numbers, the measurement of angle ABD plus the measurement of angle DBC is equal to the measurement of ABC. Now these theorems, okay, here we go. These are the theorems. Vertical angles theorem says if two angles are vertical, then they are congruent. Notice it is an if-then statement. If two angles are vertical, then they are congruent. Complementary theorem, again, it's an if-then statement. If two angles form a right angle, then they are complementary. So if it forms a right angle, then it's complementary. Complement theorem. Supplement theorem says if two angles form a linear pair, then they are supplementary. If it is a linear pair, then it is supplementary. Congruent complements theorem. Notice this one. I want you to star these two. So if angle A is complementary to B and angle C is complementary to B, then angle A is congruent to angle C. So you'll notice the congruency part. Angle A is congruent to angle C. This part, to me, looks like the transitive property. If angle A is complementary to B and B is complementary to C, then my B middleman cancels out and angle A is congruent to angle C. So I kind of look at this as two properties rolled into one. You've got the congruency property and the transitive property, okay? Same thing with congruent supplements theorems. If angle A is supplementary to angle B and angle C is supplementary to angle B, my middleman, that angle B is kind of canceling out, saying that then angle A is congruent to angle C. So that's kind of a look at the angle, some of the reasonings for those proof statements. So flip over your paper. I know you have it. And let's take a look at these. So I'm going to give you a second. You know what? Pause the video and take a second to see if you can fill these out. Okay, here we go. So, number one, here's that if-then statement. If angle A is a right angle, then the measurement of angle A equals 90 degrees. That is definition of a right angle. I'm going to abbreviate, you cannot, of a right angle. If angle X is supplementary to angle Y and angle X is supplementary to angle Z, notice my Y statements are going to cancel out, my X statements are going to cancel out, and now I can say that angle Y is congruent to angle Z. That's that two properties into one. So that is that congruent supplement theorem. congruent supplement theorem. If angle 1 is across from angle 2, then angle 1 is congruent to angle 2. That's your definition of vertical angles. No, it's not. It's the vertical angle theorem. Sorry, that's a theorem. Vertical angle theorem. Not definition. All right, number 4. If measurement of angle P is equal to, if these are equal to 90, then angle P and angle Q are complementary. That is your definition of complementary angles. Number 5, if they form a right angle, then they are complementary. So number 5 is the complement theorem. All right, number 6. If I look at that picture and your L is perpendicular to M, then angle 1 is a right angle. So number 6 is definition of perpendicular. Number 7. If angle W and angle X are supplementary, then angle W plus angle X equals 180 degrees. That is definition of supplementary angles. All right, so here's that congruency, kind of transitive property congruency statement into one. So number 8 is congruent supplement theorem. No, it's not. It's congruent complement theorem. They're complementary angles. Complement theorem. Number 9, if A and B form a linear pair, then A and B are supplementary. That is going to be a supplement theorem. If angle N and angle P are complementary, then the measures are equal to 90 degrees. That is definition of complementary angles. And then, of course, number 11 is angle addition postulate. Very, very similar to segment addition postulate. And number 12, if measurement of angle R is equal to the measurement of angle S, then we put those congruency marks on. So that is definition of congruence. Definition of congruence. So that should be practice to help you get through that. And then, of course, we're going to piecemeal the angle proofs together. Good luck.